Okay, this little tutorial is going to be looking at making sure you understand the difference between the words chromatid, chromosome, and also the term homologous chromosomes. Okay, it's probably one of the biggest misconceptions in genetics in this topic, and people get very, very confused. So, I'm going to show you a series of diagrams that hopefully will help you to understand the difference. So, now this first diagram shows two different chromosomes. Okay. Now this could be a homologous pair of chromosomes. What that means is one might have been inherited from the mother and one from the father, and that they both have the same genes on them, i.e. for the same characteristics, for example eye colour, but they might well have different versions of that gene. Remember, that's what we call alleles. Now you'll see that each one is just a single chromosome. And we might term these chromatids because there's just the one. Now, after DNA replication, we end up with two. That's where the word chromatid becomes very important, because now we have to distinguish between the fact that this, which we could call, and let me just highlight what I'm talking about. This we could refer to as a chromosome, but we'd have to recognize that this is made up of two identical copies. Okay, so this one here, and this one here. Now, each of those we can refer to as a chromatid. They're just absolute identical copies of each other. Okay, and the same has happened with the other of the homologous pair. It's an identical copy. Okay, let's move on to some other diagrams to help us. This is a nice diagram. This is just showing us one chromosome made up of two chromatids. Okay, this centromere thing that it's mentioned in the middle, this is basically a point where the two chromatids are joined together. Okay, so that's what is meant by the term centromere. In this diagram, we're just again showing homologous pair of chromosomes and distinguishing between the two chromatids. You'll also notice the term sister chromatids, so we can use this term when we're talking about the two identical chromatids. But notice that, for example, capital A, this chromatid, is not identical to this chromatid, but it does code for the same genes. Okay, so this has all the same genes on it, i.e. for the certain characteristics such as eye colour or hair colour, whatever's on this particular chromosome. It'll marry up with the genes on here, but the versions of those genes, the alleles, may well be different. Chances are most of them will be very much the same, but there'll be some differences, and that's what makes us all different. Okay, this one here shows what we call a karyotype. Okay, now this shows as a visual representation of all of the chromosomes in a single cell. Okay, now you'll notice that this is made up of pairs. So if we look at this one here, again, it's showing what we were looking at previously. It's a pair, a homologous pair. Okay, and they look like X's because this is after replication. So each X is made up of two chromatids, two here, two here. This one's actually got a number, number 6, and you'll notice that everyone is numbered. And those numbers aren't meaningless. We've numbered all of the chromosomes, and we actually have a very good idea of what genes we find on what number chromosome. Particularly interesting one are these ones. The 23rd pair, we actually give letters, and they can either be two X's or X and Y, and that's what determines sex, gender. Okay, so we've got 23 pairs of chromosomes, and if we wanted to talk about chromatids again, we could say that altogether there are 92 chromatids.